Namastey Coders, I hope you are fine. So today is 22 March and we are gonna solve LeetCode problem of the day. Right, so today's problem is medium problem and the it belongs to the graph, right? So this problem is count the number of complete component. Okay, and what is the complete component? So let me explain you the component first. So component is the part of a graph which is which which is which is a yeah. So the component is a subgraph of a graph, right, which has a separate connections, right? So these three are the components of a graph, right? And complete component is a component in which all the nodes are connected with each other. So let's say this node is connected with these two nodes, this node is connected with these two nodes, and also this node is connected with these two nodes. So this is a complete component. This is also a complete component because this has only a one node, and this is also a complete component because these two nodes are connected with each other, right? Now talking about these two graphs, so this is a component and this is a component because these are the separate groups. Okay, so this is a complete component because all three nodes are connected with each other, but this is not a complete component because these two nodes are not connected, right? So in this case our answer is 1 because there is only a one complete component in this particular graph, right? In this case answer is 3 because there are 3 complete components. Okay, so this is the question. You are given an integer undirected graph with n vertices, number from 0 to n minus 1. You are given 2D integer array edges where edge is I is ai bi. Note there is undirected edge connected vertices ai and bi. So this is the standard graph which is given to us using edges. We have to find complete component. The connected component are the subgraph of the graph in which there exists a path between any two vertices, and no vertices of a subgraph shares the edges with the vertices outside the subgraph, right? So this is a component similar to this definition, and connected component is said to be complete if there exist edges between any pair of its vertices. So this is the definition of complete component. So we have to find the number of complete components. So before starting the solution, let me know you that this video is a part of our LeetCode problem of the day series, in which I am solving all the LeetCode problem of the day daily, right? So the link of the playlist is given in the description box. So if you want to go through the previous problem of the day videos, so you can go through those videos as well. Along with this LeetCode problem of the day, I have also started the LeetCode 75, right? So LeetCode 75 is the most important 75 questions of LeetCode, which is most probably coming into your interview. So if you want to solve those 75 problems, you want the explanation of the detailed explanation of those 75 problems, you can go through that playlist also, right? I am currently solving those problems as well. Okay, so along with these two playlists, I have also created a WhatsApp group for the coders. So if you want to be a part of a coding community, you can join that group as well. Okay, now let's start with the solution. So now let's start with the problem. So the problem is count number of complete components. Okay, so as you can see, the problem is from graph, right? And how do we find the number of components in the graph that we have already seen in the previous videos? So let me explain to you again. We can do it using breadth first search or depth first search, but we will use breadth first search here, right? So in a graph we do have two types of algorithm for searching, right? First is BFS. If you are not aware about these two algorithms, right, BFS and DFS, I will highly suggest you to go through my previous videos in which I have explained these BFS and DFS in a depth, right? And also, if you want a depth video over the graph theory, so graph includes multiple things, including topological search, BFS, DFS in degrees, and all those things. So if you want a video dedicated to the graph theory, I will do that also, right? Okay, now this problem will be solved using BFS. So we can find the total number of components. We can find all these things, like, right, how many nodes are there in a component, how many components are there. If you have aware about the problem number of Iceland, right, so that will also be then using the similar kind of a algorithm which is called BFS. So what we will do, first we will find the component, right, and then we will iterate in the component, mark all the nodes visited, and we will count those nodes as well. Okay, we'll count those nodes as well, and then what we will do, we will find from all these nodes, right, we will store those nodes, right, in that this component too, let's say this is the second component will contain these three nodes, so we will put them in the set, and then we will iterate through every node once again. First of all, we have to find the number of nodes in the component, and we will store all those nodes, and then again we will iterate through all those nodes, and we will find the number of adjacent a number of neighbors that node has, right? So this node has two neighbors. So if the number of neighbors is equals to total number of nodes in the component minus 1, that means this node is connected with every other node, right? So that is one thing. The thing what we can do is we can also find the number of edges in a node, in a component, right? We can also calculate that. We can find the number of edges in a component, and if edges are equals to n plus 1 by 2, that means that component is a fully connected component. So this is a other thing, right? So if all the nodes are connected with each other, the number of edges must be n plus 1 by 2. So these are the two things which we can do. So I am doing the first wala thing, right? So okay, now so I hope you understand this approach, right? What we will do is we will iterate through every component one by one, and we will put the nodes of that component inside the set, and again we will iterate through every node inside the set. That means every node inside the component, and we will check that if the node has n minus 1 component, n minus 1 neighbors, that means the node is connected with every other node. So if all the nodes have n minus 1 neighbors, that means the graph is fully the component is fully connected. So we will put the component in the answer. So let's see the code. Okay, so first of all, we are making a graph which is adjacency array of the graph. What are we doing is we are putting all the neighbors. So if A and B are sharing a edge, that means A is a neighbor, B is a neighbor of A, and A is a neighbor of B, right? So now we are creating a visited graph, and then we will iterate through all the nodes, and if node is not visited, if node is visited, then we will not do anything on that node, and if the node is not visited, then we will do the BFS, right? So this is the algorithm of BFS. We are using Q for the BFS as obvious, and this is the set in which we will insert the nodes of that component, right? Then we'll so here we are inserting the nodes. Now after completing the BFS, k is the size of sets. That means the k is the number of nodes inside the component. Now this is a flag which we are using for every node inside the set. If the graph, if the number of neighbors of that set is equals to k minus 1, k is nothing but the size of set, the number of nodes inside the component. So if the neighbors of that node is equals to k minus 1, is not equals to k minus 1, that means the graph is not fully connected. So we'll make the flag false and return and break the loop. And if we have a flag, right, that means if we are not breaking any condition, that means the graph is fully connected and we'll increase our answer. So that is all we want now. So that is all in this video. I hope you understand this well. So if you have any doubt, any suggestion or anything, you can ask or share those things directly in the comment section, or else you can also join the WhatsApp group where we can discuss personally on the chat. So thank you. Have a nice day.